Like the question
Class started?
greater than or
Yeah, if that is the then you have
No.
that is the you have to greater than 820 we can
Okay.
Basically, the traversal is based on some marks which are already found.
N2 is 5 and you calculate with. So N1 is 7. Fine. Next, let's go to N2. What is N2? N2 is minimum number of nodes that should be accessed in order to fetch all records we search to greater than or equal to 5 and less than 30. Not less than or equal to 30. So what will be the first? 8. Then from 8 to 3. Okay. Then from 3 to
Hello.
5. Not here.
Professor?
Then 8:30. Then from 8:30 to
Hello.
21:30. Okay, we have to access
Hello,
this
sir.
node. Accessing one node
Sorry.
21.
Sorry.
No problem. It's okay. You're... It's okay, everyone. It happens.
I muted, but it went twice actually. Sorry.
Yeah, no problem. It happens.
Sorry, brother.
No. It's okay. Don't be sorry for it.
Okay, good evening everyone. Am I audible?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
for those who don't know me, I am Krishna and I am DBMS TA for Desktop. There has been some problem with user, so he couldn't come today. So I'll be taking today's session, and this is revision session 1. So in this, we'll be discussing week 1 to 8. And first, I'll discuss concepts, and if you have any problem with those concepts, you can ask to me in between, and at the end, if time permits, so I can take like questions, doubts that you all might have. Is it fine with everyone?
Yeah.
Yes, sir.
Yes, sir.
Okay, so let's start.
Sir, you will be telling us like important topics also.
Yeah, that's what we'll be doing for week 1 to 8. We'll be discussing the important topics.
Okay, sir.
Everyone can see my screen, right?
Yes, sir.
Yes, sir.
So first of all, in week 1, there is nothing for me to discuss. You can just skim through the slides. Everything is very like theoretical only, and you can just see the slides and it will be fine. Let's start with week 2. In week 2, the important concepts are the keys which are there. So candidate key is there, which just is a minimal set of attributes which can identify all records. There is surrogate key, simple keys. These are some concepts which you can just brush up quickly. This is not of much of that importance that might be coming. The important part in week 2 is these things. So first of all, let's go with all the revision with all the variables.
Sir,
This is the yes.
sir, could you please zoom in?
What?
Zoom in, please, sir.
Yeah, okay. So in this one, the first important thing is these variables. You might know what is the meaning of all of them. So first one is selection, and this one is used as projection. This one is called negation. This is used for AND when we want to compare two statements. This one is for OR. This is union, intersection, Cartesian product. This is for set difference, and this is natural join. And now we'll be using them one by one. These are used in relational algebra to perform different queries on our database. Okay, so first one is this, which is saying that we have to select A equal to B and D is greater than 5. Okay, so this is our original relation, and in this we have to find those values where the value of A and B is equal and D is greater than 5. Then this is the projection operation, where it is simply saying that we need to project column A and column C. Okay, then there are union, there is set difference, intersection, Cartesian product. Any one of you having any problem with union, difference, intersection, Cartesian product, or natural join, anything?
No, sir.
No, sir.
No, sir.
No, everyone knows this concept, right? One important thing to tell is, what does natural join do? It merges two relations on the basis of common attributes, right? So if there is one common attribute, it will join with regard to that attribute. If there are more than two attributes, it will join with more than two attributes. It will then take the combination of all, right?
Yeah.
And if there are no common attributes between tables, then what will natural join do?
Cross product.
It will
It
be
called.
showing the it will be showing the Cartesian product. Okay. Then what are DDL, data definition language? Data definition language means whatever we are writing about the data itself, which contains the information about the data itself. So creating data or creating the schema of the data, all those things are covered in DDL. Okay. Then when we talk about DML, what is DML means? Data manipulation language. And what does data manipulation language do? All the operations that we need to perform on particular rows or particular columns, all those things are done by DML. Okay. Now there is select clause. So from here on, we'll start with SQL part. So first thing is select clause. What does select clause do? After select, whatever attribute name we write, it will simply show those attributes. So what is the work of select? It simply shows us the attributes which we tell them. Now if we write select star, what will it do? Select star
Select all the
simply
columns.
gives all
Gives
the
you all the
columns.
attributes.
It will show you all the columns of the table. Okay. Then there is a from clause. What does from clause do? In from, we write the table, the name of the table which we want to display. Anyone having problem with select clause or from clause?
No, sir.
No,
No,
sir.
Then okay, then there is where clause. In where clause, what do? We specify the condition for filtering. Suppose you want to display those students whose marks are greater than 50. So you are providing a condition that marks should be greater than 50. So for providing any condition, for applying any filter in our rows, we use the where clause. Okay. Just stop me and tell me whenever you face any problem with anything. Okay? Then there is string operation. This is used for pattern matching part. For example, if you want to display those students whose name starts with A, or you want to display those students whose last name have V in the as a word. So for those things, we use string operation, and in string operation, we use the word like. Okay, so how we do it? We do this by where student name like, and then we provide our pattern matching way. In pattern matching, there are two things. One is percentage sign and other is underscore sign. What does percentage do? It means that there can be either zero or more than zero characters present there. And what does underscore means? That there should be at least one character present there, right? So when we are writing three underscore here, what does it means? That there compulsorily has to be three characters present there. And when we are writing three underscore and then a percentage, what does it mean? That minimum three characters are there, but more than three characters can also be there because there is a percentage sign. Anyone having any problem in string operations?
No, sir. No, sir.
No, sir.
Sir, excuse me, but I have a doubt. In DDL part, where you
you
said
can
it
use
is
length also, right?
data definition language, so it creates a table or drops a table. And if we want
It
to uh, delete
Krishna
one
sir, we can
particular
use
row,
length also, right?
What?
Length for the at least characters.
Yeah, we can use that also.
so
Yeah,
if we
see,
want
if
to,
we are performing any row operation, then
yeah,
we use DML. That comes in DML. But when we are performing directly on the schema of the table, right? Whatever table we have, we are manipulating the schema. For example, here you are creating a table that is directly influencing your schema, right? When
yeah,
you are dropping some table, this is also
yes,
influencing your schema. So whenever you are doing something which is directly influencing your schema, your database, those comes in DDL, and in DML comes which you do inside the table. It can be anything with row, like some filter you are performing or you are displaying something. All those things come under DML.
Okay, so altering a column also comes like dropping an attribute.
So then, yeah, correct. Okay, then there is where clause. Okay, then there is between. Whenever you want to provide a range, for example, here the question was that you want to select the name of those instructor whose salary was between 90,000 and 1 lakh. So for that we use between clause. How do we use that? We first write the name of the column, then we write between, and then we provide the range with and. Okay, and in this, one important thing to note is that 90,000 and 1 lakh, both of them are inclusive. Okay. Then there is in. Suppose you want to search for department name which are more than one. So one way is where you are writing continuously, that where department name equal to computer science, or department name equal to biology, or department name equal to something. But the other way to do the same thing in lesser words is that we write department name in, and then we provide a list which will have all the values whichever can come in department name. So what does in means? That any of these values can be there of department name which we want to display. So it works like or only. Anyone having doubt till now in anything?
No, sir.
No.
Then there is
Sir, your voice is breaking.
Yeah.
first. Yes, someone was saying something.
Your voice is breaking like yesterday.
Okay. Is it fine now?
Yeah, now it's okay.
Yeah.
Yes, sir.
Now it is.
What kind of question will come from this part, sir?
Basic questions can come, like they can give you some query and you have to see what this query is doing. So these type of one or two questions can come from this. So we are just quickly brushing through these concepts so that like if questions come we can properly do them. Okay, so everyone understand what is union, intersect and accept, right? Now what is the difference between union and union all? In union we will only get the unique values, but in union all, intersect all and accept all, you are also going to get duplicate values. That means that if a value is same in two rows, that value will be displayed two times only. So that is the main difference between normal one and all one. Okay. Then there is group by clause. What is the use of group by clause? When we want to group any particular attribute on the basis of some values. Okay, so whenever you want to group group anything, so fine. Arup, can you please mute yourself? Okay, so what does group do? For example, in our any attribute, we have some common values and we want to group according to those values. In that case, we use group by word. Okay, so for example, in department name, there can be many entries which has CS as a department. There can be many entries which have electrical as department. So whenever we want to group them, then we use group by clause. And what does having do? Whenever we want to provide any condition in the grouping, then we use having. Everyone please be very careful with the difference between where and having. Where makes the where is used for applying filter on individual rows, but having is used to provide filter to groups. Okay, so
Okay.
this was the week 2. Now let's go with week 3. Yeah, everyone is on the same page right now, right?
Sir, I have a doubt.
Yes.
Sir, what is data dictionary? Could you please explain?
Data dictionary simply just means the schema of the table. Whatever table you have in whatever attributes are there, so that is only called data dictionary. The way of providing the details of your table, that is can be called as data dictionary. For example, when your attribute is there, so that attribute has what variable type is there and everything, so all those things are understood by data dictionary. So in week 3,
Okay,
the
sir.
first concept is distinct and all. So what does distinct do? It will only provide the unique values. And what will all do? It will provide all the values. Now by default, what is by default, distinct or all?
Distinct.
Hmm. By default, I'm asking.
All.
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 All. Right. See, if you talk about relational algebra, in that case, it's fine. In relational algebra, the by default thing is distinct, where only unique values are shown. But when you are talking about SQL, in this case, all is by default. So always remember this thing in your mind. Okay. Then there is as operation. What
Hello,
is the
sir.
use of as? Yes.
Can you please repeat again?
I am saying that there are two things, distinct and all. What does distinct do? It will provide unique values. Like if any value is repeated in two rows, then it will only show one as a result. But what does all do? It will show all the duplicate values also. As you can see in the example, we are just uh, we are extracting building attribute, and we have written distinct, so it is only showing Packard, Painter, Taylor and Watson. But here you can see that Watson is written two times and it is also displaying two times. So that is the difference between distinct and all. Now I ask that what is the thing that we use by default. So if we talk about relational algebra, you all might remember relational algebra, right? So in relational algebra, by default, only unique values are shown. That is in relational algebra, distinct is by default. But when you talk about MySQL, in that case, all is by default. In SQL, duplicate values are shown by default, and in relational algebra, unique values are only shown. Is it fine?
Yes, sir. Thank you.
Okay. Then there is as operation. What does as operation do? It is used to rename some column. For example, this has like various applications. One of them is you just simply want to rename a column. Other is that when you perform any operations on particular attribute and you display that attribute, usually it don't get a name or it gets a very strange name. For example, when you apply count and you display that count, by default the name of the column also comes as count or something. So if you want to change that name, so in that case you can use as operation to rename the column. Okay. Then there are nested queries which are used for efficient coding. Okay. So whenever we write a query inside a query, okay, that is called as nested query. Then there are some clauses which are present in nested query. One is sum clause. What does sum clause do? After sum, we provide some series of arguments, series of numbers, and we say that if any one of them is true, then the result will be true. Some clause and all clause both provide true and false as the result. Okay. When you get true result in sum, when at least one of the value present inside is making the condition true, and if none of them is not making the condition true, then it will be false. Here you can see 5 is greater than sum of 0, 5, 6. So 5 is greater than 0, but 5 is not greater than 5 and 5 is not greater than 6 also. So only 0 is there which is making the condition true. Then also the answer will be true. Okay. But suppose if here it was 7, 5 and 6, in that case the answer would have been false because any of the values present inside is not giving you the answer as true. What does all clause do? In this, all the values which are present inside, it should satisfy the condition. That means when we are saying 7 is greater than all 0, 5, 6, it will return true only when 7 is greater than all the values. So everyone understood sum and all clause?
Yes, sir.
Yes, sir.
In operator, I have already told. Okay. Except is as simple as that except just simply do difference between two tables. So that's what here it is being done. Everyone know what is the meaning of subtraction. So that is what except clause do. What is the use of average clause? It is used for doing average. Okay, so that's what here they have done. They are just finding the average capacity of every building. So it's not much of that thing. Minimum clause is used for finding the minimum. Just like go through this slides and understand how they are used. Just what does they do? It is not a big thing. Then there is max, there is count function, sum function. Okay, now there come exist clause. Okay, now comes the exist clause. What does exist clause do? It just simply gives the answer as true or false. Okay, exist just work as this way. It does not return you any row or something. What does it do? If the answer of inside query is having any row, then it will return true as the answer. And if it is not returning any row, if the answer inside is 0 rows, then it will return true. For example, if you want to select course ID where semester is fall, year is 2009, and there should be at least one row such that the semester is spring, year is 2000. Okay, so what does exist clause do? It simply gives you the answer as true or false. If there are rows, it will give you true. If there are no rows in the subquery, it will give you true. If there are no rows in the subquery, it will give you false as the result. Similarly goes with not exist also. It will give you result for true if there is 0 rows, and if there are no 0 rows, if there are more than one row, then it will give you false as the answer. It is just opposite of exist. Then with clause is there, which is just written in same way only. There is not much. Then there is insertion. Okay, so whenever you want to insert any row into our database, so these are the ways in which we do it. Okay, one of them is insert into course, and then we provide values. Now these values are provided line by line for every column. For example, if first column is roll number, then this is the one that we have to provide first. So it has to be in accordance to our column serial only. And if it is not according to our column serial, then we have to mention it manually. For example, if you want that you are providing title first, course ID afterwards, so here also you have to disturb the serial, then only you can change the values here. Okay, suppose you want the database systems you want to write first and CS437 right afterwards, so the same thing you have to do up also. That is the main difference. Then there is update, which what it simply does, it simply update a particular attribute with some filter in it. So it is directly used for applying directly and for any particular attribute, applying for every row. Then we use update. So what they are doing, as you can see, update instructor set salary equal to salary into 1.03. So it is applying for all the rows in salary where salary is 1 lakh. So in all the rows where salary is 1 lakh, it is directly applying this value. Then there are different types of joins which are present. Cross join, inner join, natural join, full outer join, left outer join, right outer join, and natural full outer join. What does cross join do? Cartesian product, correct? What does inner join do? It just do the intersection. Okay. Then there is natural join. We all have seen it. What does full outer join do? It do a union and uses null values. And then there is left outer join, which just simply is the intersection of A and B and the rest of the values of left table. What is right outer join? Intersection of both the tables and the leftover rows of right one. Then there is natural full outer join, which will do the union of both. Then views you can leave, triggers you can leave. You don't have to worry about views and triggers. Then there is week 4. In week 4, first is division operator. Everyone knows what does division operator do, right?
So can you go through this concept?
For division operator?
Yes.
Yeah.
So basically, for any unique value in A, if we get the value of B, if all the values of B we get, for example, what are the unique values of A here? Alpha, beta, gamma, and delta, correct? And epsilon also. Now for whatever these unique values, if we get all the values which are present in B, that means that in alpha also 1 and 2 is there, in beta also 1 and 2 is there, in gamma also 1 and 2 is there. So we will check this way, that for whatever unique value of A, if the value of B is all the one which are present in S, those value we will display. So you can see for alpha the value is 1 and 2, for beta the value is 1 and 2. Now for gamma, if you see, it is only 1, so we will not take this. If you go for delta, you can see it is 1, 3 and 4, so again we will not go with it. If you see for epsilon, it is 6 and 1, but the value should necessarily be 1 and 2. So if these both are present for any unique value in A, then we display that result. Okay.
Yeah.
Okay, then there is a tuple relational calculus, which we write in this way. Okay, wait a second, I'll give a more prepared notation. Okay, yeah, let's go with this question and we'll understand TRC and DRC with this. Okay, first of all, TRC is written in this way, the B, C and E. These three you can see, these are the one which are the way how we write TRC. And DRC we write in the way A and C is written, A and D is written. These are the way that we write DRC. Okay. Now we have been given a table customer, product and order. And we need to find the name of the customer who has ordered the product named belts. Okay. Now tell me which of the operations can work on this one. And for the first question, which of these can work? So for DRC, what we do, first we will talk about DRC. Okay. So in DRC, whatever number of attributes we need, we first check that. So how many number of attributes is the question asking to us?
One.
Only one, which is name. So first let's check in A and D option, which of them is showing only one word?
A.
A.
Oh, that means D cannot be the option. Why? Because D is displaying two attributes here and A is displaying only one. Now what they are saying? B, where A, B, C belong to customer. And when they are saying A, B, C belong to customer, what does it mean? That A is CID, B is CNAME, and C is age. Okay, this is how we read this. And then they are writing AND. And after AND, what they are saying, there exists DEF, where DEF belong to product. And what does this mean? That D is PID, E is PNAME, and F is price. Now you can see that first thing to notice was here that they have said that ABC belong to customer. So what does B means? B means CNAME, right? And what they are displaying here? B. That means they are displaying name here. So this part is right. Now what they are saying? And E equal to belts. So they have said that the name of the product should be belt. Now tell me DEF belong to product. So what is E? E is P name. And they are saying
Product name.
that E equal, yeah. So here they are also saying E equal to belt. So that means this is also fine. Now what they are saying? And there exists GHI such that GHI belong to order. And what will this means? That G is OID, H is CID, and I is PID. After that, after writing all these things for different tables, see we have three tables. So we have mentioned variable, all the columns of the variable, right? And then we will join them. So just tell me, how will customer and order will join?
A and H.
Y product.
CID.
CID.
Think CID and CID. Now, what was CID here? It was A, right? And what
Yes,
was CID here? It was H.
H.
So what we will write?
H.
A equal to H. Similarly, how will product and order will be joined? Using PID. Now, what was PID here? It was D. And what was PID here? It was I. So now we will do D equal to I. So first we write the name of the tables, and we provide every attribute a variable, and then we join the tables with that variable, and in outer side we write the variable that we want to display. So it was just D. Everyone will clear with how we do DRC?
Yes.
Yes.
Correct. Now, similarly, let's see for other things also. Let's look at every option. Let's look for B option. Now we'll understand TRC and how we write it. Okay. In TRC, what they are saying that there is P where there exists C belonging to customer. When they are writing it this way, what does C means? Tell me here.
Relation.
Yeah, C simply means a relation. That means all rows. Okay. So they are saying that C is customer, P is product, and O is order. Then what they are saying? They are saying that they have joined C.CID and O.CID. So they have joined customer and order using CID. Then they have joined product and order using PID. And then they are saying that P.PName equal to belts. Okay, so that's what they have done. First, they have given 3 tables. Then they told that we will join these tables, and then they provide the name of the product.
Sir, could you just explain the last part that is from orders again, please?
Uh, the
In B from
B was-
orders on how they joined it.
Okay, so what they have done is they have first simply here see in DRC we provide the attribute name, correct?
Yes,
But
sir.
in TRC we provide row. So here when we are saying P means a particular row.
Okay.
Okay. Now when they are saying there exists C belonging to customer, this means that every row is C. Every row in customer is C. That is what is meaning of C. When they
Yes.
are saying there exists P to product, that again means that P will be denoting the rows of product. Similarly goes with order.
Yes.
Now what they are saying that C.CID equal to O.CID. Now what was C denoting? Rows in customer. And what is O denoting? Rows
Oh,
in order.
order.
Okay,
Yes.
so they are saying now we will join CID of C and O. Similarly, in product also we provide the product we change to P, and O is denoting the rows of order.
Yes,
So
sir.
we have joined these two using PID. And then finally we told them that P.PName equal to belt. That means that in product table the PName should be belts and display those P.
Got it, sir.
Okay,
So thank you.
yeah. So let's see the next one. Next one is they are showing T where exists C, P, and E. The same thing is there. Now they are saying that T.PName equal to P.PName. Okay. Then they are saying T.price. Okay, this is for our second question, I guess. Yeah, I'm sorry.
Yes.
So basically, the main thing that I wanted you all was to understand how we write TRC and DRC. So
Sir,
I told with each and every word how we read these things.
sir, this option B is wrong, right?
Yeah, B option is wrong. I was just
Okay.
telling you how we read this. The option is
Yeah,
wrong
yeah.
because again the things are
We are
missing.
not returning the name.
Correct, correct. Okay. Mm, I don't. Okay, there was one question I remember in the PYQs where some 5 6 questions were there, and there were so many TRC and DRC. We discussed in using you in quiz one time, if you remember. So if you can get me that question, we can like do TRC and DRC with that. Till then, now we'll come to entity set. Okay, so in entity set, first thing is what is entity? Entity simply means an object, or here in our case, we can say a relation. Okay, and what is entity set? A set of all the entities or a set of so many relations. Now, what is strong entity set? that entity set which already have sufficient attributes which can uniquely identify all the records, okay, which is having its own primary key. Those are called as a strong entity set. Now, what is weak entity set? Which does not have those many sufficient attributes so that they can uniquely identify itself. They don't have their own individuality. They need strong entity set to determine themselves. So every weak entity set definitely has a strong entity set associated with it. Okay, and there is a partial key in a weak entity set that is called as a discriminator, and it is represented by an underlining dashed line. We'll see it in like afterwards. Then there are attributes. Everyone know what attributes are, right?
Yeah.
Okay, now let's see different types of relationships. So one is one-to-one relationships, which we show using arrows. So when you see two arrows which are pointing like this, then we know that there is a one-to-one relationship. What does one-to-one relationship means? That one instructor can have only one student, and one student can have only one instructor. Okay, that is the meaning of one-to-one relationship. Now, when we go to one-to-many relationship, what does it mean? That each instructor can have one or many students, but one student can have only one instructor, and this you can see by these arrows. Okay. Then there is many to one, where again the thing is that instructor can have at most one student only, but one student can have many instructors. Then in many to many, it is that one instructor can have many students and one student can have many instructors. If you are facing a major problem in this part, so you can see the last TA session before quiz 1 revision. So in that I have in very good detail I have covered all the ER diagram, and also I have prepared a PPT which I'll be presenting in tomorrow's TA session. So those who are facing problem with reading ER diagram, please join tomorrow's session. There we will cover this in proper detail. Okay, today we have much more greater aspects to cover, so we will do it afterwards. Then there is total and partial participation. Okay, so total participation is denoted by double lines and partial participation is denoted by single line. So what does this means? That here one line is there, here two lines is there. That means that every student will definitely have some instructor, but instructor may have some student and it may also not have any student. Then this is the way of expressing a weak entity set, where you can see this one is a weak entity set section, and these are the keys of this entity set which are represented by dashed lines. Then there is ternary relationship, where there is a relationship between more than two tables, that is known as ternary. Okay. These ER diagram part, for this ER diagram part, please join tomorrow's session. This all we will cover in great detail tomorrow, because if we start doing it now, it will cover most of our time. Is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
Now comes week 5. Okay, so week 5 and week 6, as you all know, it's very important. So let's understand everything very carefully now. In FD, what does FD means? That if any value of X is being repeated, then its corresponding value of Y should be same, right? So for example, if the value of 1 is repeating and the value of B is X, and we are saying that A is determining B, what does it mean? That if value of 1, if the value of A is 1 and the value of B is X, then in the next row also, if the value of A is 1, the value of B should be X. Here A determining B is not a correct FD. But when we say A determining C, is that a FD? Yes,
Yes.
it's FD. How?
Yes,
Because
sir.
when the value of 1 is repeating, the value of C is also repeating, whether it is 1 or 2. Every one concept is clear for FD, right?
Yeah.
Yes, sir.
Yes.
Now there are different types of FD, that is trivial, non-trivial and semi-trivial. What does trivial FD mean? Whenever on RHS side, we have a subset of LHS. Then we say that it is a trivial FD. What does non-trivial FD means? When there are no common attribute between LHS side and RHS side, then it is called as non-trivial FD. When it is a non-trivial FD, when there is some common attribute between LHS and RHS, but RHS also have some extra value. So similarly, if you see example, AB determining B. So B is subset of AB, so this will come under trivial FD. In non-trivial, you can see AB determining CD. So AB and CD both are not having any common attribute. So this will come under non-trivial FD. What comes under semi-trivial FD? In this, there might be there are some common attributes. So you can see B is a common attribute, but there are some other extra attribute also. So this comes under semi-trivial FD. Now, what is attribute closure? Whenever we talk about attribute closure, it simply means that we are saying one attribute can determine how many other values with it that we find using attribute closure. Okay, so let's do this simple exercise very quickly. We'll do just some questions and we'll understand this. Okay, so what is the closure of C here?
C.
Only
C.
C. Because C is not determining any other attribute.
Only C.
Only C, sir.
Okay, now let me tell you one important concept here. Yeah, so see, if we are taking closure of A, yeah, if we are taking closure of A, in that case, we cannot consider this FD. Why? Because it also have B in it. So the closure of A will be A only. But if I say that I want the closure of A, B, D, in that case, we will take this closure into account because D is separate here. We will not say that here we are talking A, B, D and here only D is there, so we will not take this FD. We will take this FD also because it is single. But here, there one extra attribute was there which we were not taking into account. So we will not take this into account. Everyone understood this?
Yes.
Okay.
Yeah.
Okay. Now tell me what is the closure of BC in this?
A, D, B, C.
B, C, A, D, E, G.
Yeah, G also.
Yeah. Okay. So everyone is very well brushed with this concept, right? Attribute closure. I don't have to tell this.
Yes,
Robert.
sir.
Now, what is super key and candidate key? First of all, let's talk about super key. What is a super key? When we find the closure of any attribute set and it is giving us all the attributes which are present in our relation, then it is called as a super key. Now, what is the difference between super key and candidate key? Candidate key are those where we are taking closure, it is giving all the attributes of our relation, but it is the minimal. For example, suppose there is a relation where you say that when I took the closure of A, B, D, and I am getting all the attributes which are present in the relation. So this will be considered as a super key. But when I am saying that also if I take closure of AB, then also I am getting all the relations of our all the attributes of the table, then this will be considered as a candidate key. So minimum subset of attribute which can determine all our attributes, that is called as candidate key. Second thing where people get confused in this is, tell me one thing, if I say AB and if I say E and I say both of them, when I take closure of both, they are determining all the attributes. So now just tell me that which of these are candidate keys.
So E is
Both are candidate keys.
Both are
Both are candidate keys.
All
Both are
together.
candidate keys. Okay. You might say that we take minimal only, so that's why only E should be there. Why AB is there? It is having two attributes. But see, minimal is taken in its own way. E is not minimal of AB. right? If I say that A, B, C, and then I say AB, so AB is minimal of ABC. If I say A, C, E, and then I'm saying E is also giving all the attributes, in that case, E will be candidate key and this will be super key. Why? Because E is a minimal subset of this attribute. But A, B, and E, these do not have anything in common. These are totally separate. So this will also be considered as a candidate key, and this one will also be. Everyone understood this?
Sir,
Yes.
in quiz 2, there was a question about they are given a relation and then three functional dependencies. We had to
Okay.
find the value of m plus another variable, which is a total number of candidate keys in the relation. Could you
Okay.
please do a question based on that?
Yeah, sure.
Yes,
I
sir.
have questions, and I have questions regarding to that also, and I have mentioned some simple steps. Those who follow TA session, they know. I have some steps for that also. We'll cover it in some time. Okay.
Okay, sir.
In this only I have.
Thank you.
Then this redundancy, anomaly, and everything. These are just conceptual based thing. I'll not waste my time on this. You can just read them. Okay. Why do we need decomposition and everything? Now there comes two things, which is types of decomposition. So what does the meaning of decomposition? It means breaking our relationship, breaking our relation into more tables. Okay. So what does there are two types of decomposition. One is lossy decomposition, one is lossless decomposition. What is the meaning of lossy decomposition? When in our decomposition we are losing information, that is called as lossy decomposition. And when we are not losing any information, that is called as lossless decomposition. So, or in simple words, we can say it this way also, that suppose there was our relation R. Now we broke it into R1 and R2. Now when we are taking natural join of R1 and R2, it should give us R back. If we have more decomposition, same goes. If we say we decomposed into R1, R2, R3, R4. In that case also, when we are taking natural join of all of these, then it should give us our original R. Then it is not a lossy decomposition. And it means that decomposition of all. You can't say that only decomposition of R1 and R2, only natural join of R1 and R2 we are doing, it should give R. No. Natural join of taking natural join of all four relation, then we should get our original relation R. Then we can say that it is a lossless decomposition. Okay. Now, what are the conditions to check for lossless decomposition? First condition is that when we are doing union of both, that means that when we are doing a union of attributes of R1 and R2, it should give us the all the attributes which were present in our original relation. What is the second thing? That when we are doing intersection of two, then it should not give us a null set. It should have some attributes in common. And when we are doing a closure of intersection, it should either give us all the attributes of R1 or it should give us all the attributes of R2. We'll understand this with the help of question that I have. Okay. So first question is that this is the FD set and our relation is decomposed into R1, A, B, C, D and R2, D, E, F, G. What is the first condition? Union. So please do the union of R1 and R2. Are we getting all the attributes of R?
Yes.
Yes, sir.
Okay, when we are doing union, we are getting A, B, C, D, E, F, G. So that is fine. Second thing is that when we do intersection of our two relation, in that case, we should get at least one attribute common. Are we getting intersection at least one common attribute?
Yes, sir.
Yes.
D.
Yeah.
Yes. D. Now the third condition and the last condition is that we will take the attribute closure of that particular attribute. Like we will do the attribute closure of intersection. So what we will do? We will do the closure of D. On taking closure of D, what are we getting?
D,
D,
E,
E, F,
F,
G.
G.
Right. Now this attribute closure should give us either all the attributes of R1 or it should give us all the attributes of R2. So when taking closure of D, we are getting DEFG, which is R2. That means that this is a lossless decomposition. Everyone understood this?
Yes, sir.
Yes, sir.
Yeah.
Okay. Now for second one, I'll take, okay, this is for two relation decomposition. Two relation decomposition was easy. Now we will talk about 3-1. Okay, so first of all, first thing that we do is union. Okay, is union condition for union in 3 tables, we will directly do union of all 3. So doing union of all 3, are we getting all the attributes?
Yes, sir.
Yes, sir.
Yeah.
We are getting A, B, C, D, E, F. So first condition is true. Now for intersection, we don't take all 3 together. When we are seeing for 3 decomposition or more than 3 decomposition, what we do is we first take 2 combinations. Okay, those 2 combination can be R1 union R2, or we can take R1 union R3, or we can take R2 intersection R3. We can take any combination, and then we will find the intersection and we will take closure of it. First, let's do this much only. Just go for simplicity. I will take R1 to intersection R2. What will it give me?
C.
AC.
Now taking closure of C, what am I getting?
Sir,
No, we are
A.
getting
AC.
AC.
Okay, yeah, sorry, my bad. AC. And taking closure of AC, what are we getting?
ACBD.
ACB.
AC,
D.
B
B.
and D.
AC,
B, D, D, E,
Sir, D.
D. E.
EF.
D, E, F.
okay.
D. E. F.
That is fine. That is closure thing. The first thing that we need to see only this, that whatever table we have joined, are we getting any of the relation here? So you can see
Yes.
ABC is here.
R1 we are
That
getting.
means, oh yes. Now what we will do? We will, for checking with R3, we will do R1 union R2, and then we will do the intersection of this with R3. That means we will simply do A, B, C, D, E, and we will do the union of it with A, D, F. What will this give me?
A.
AD.
AD.
D.
AD.
Okay, and taking the union of AD, what are we getting?
ADEF.
ADEF.
D. E. F.
So is it one of the table?
Yes.
Yes.
Yes, sir.
Yes,
So
R3.
this will also become our lossless. Is it fine? Now suppose one more thing I want to tell. I don't have any question like that. Just a second. Let me check if I bought that question or not. Okay, yes, I bought that question. Let's do this one. Is this that question? Yeah, I guess it is. And for lossless, this is a very important point. So everyone understand it carefully. Please close the mic. Someone's mic is on. First, we'll be taking the union. So in taking the union, R1, union R2, union R3, union R4. What are we getting?
ABCDEF.
So this condition is true. Now we will take the union. Tell me R1 intersection R2. What it is? B. And on taking closure of B, what are we getting?
BD.
B and D. So are we getting any attribute? Any R1 or R2?
No, sir.
No,
No.
sir.
Tell me, can we directly say here that it is a lossy decomposition?
No.
Yeah.
No,
No,
sir.
sir.
What we will do?
Take
No,
another combination.
any other combination.
No,
We can check for R1
Other
intersection
combinations.
R3. Correct. So when we do this, what we will do? What we will get? AB. Now try AB. If we take AB, so what are we getting?
ABC.
ABC.
ABCD.
So we
D
already
also.
got, yeah, we'll get that. The main point is that I am just telling that one relation is getting, so I am stopped. You can find the closure properly. So we are getting one relation. So that means that still there is a hope that this can be lossless. Now what we will do? We will try to do R1, sorry. Now we will proceed further. We will do R1 union R3 and we will do intersection R2. So the main point which I wanted to, I will not solve this question full. The main point that I wanted to tell you was that if we don't find common one time, we don't stop there. When there are multiple relation, we don't stop there. We try with other combination also. There might be the case that R1 and R2 might not be having anything, but R1 and R3 might get. So we will try all the combinations. And if it is not working for any of the combination, then only we will say that it is a lossy decomposition. Everyone clear with this part?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Let's go for next part, which is dependency preservation. Okay, so whenever a relation is broken into many relation, the FD which are present in our original relation also break down. Okay, so for example, here what I did, our original relation was A, B, C, D, F, and this was our FD which we had for the relation. Now the relation was decomposed into R1 ABC, R2 BD, R3 EF, and R4 ADE. That means these FD also get splitted. But if all these FDs are present in any of one relation, then we will say that dependency is being preserved. Okay. Now we will check one by one. First FD is AB determining C. Just tell me which of the following relation can this dependency hold?
R1.
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 Now AC determining B, which one can this hold?
R1.
R1.
AD determining E, which one can this hold?
R4.
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 And B determining D.
R2.
R2.
Similarly, BC determining A
R1.
R1.
and E determining A, E determining A.
R3.
That means all the dependencies which were present in our original relation are being preserved. Other than this way, instead of directly doing this, like one is that direct dependencies are preserved. Other thing is that they are also preserved in a transitive manner. I don't have a question regarding that. If anyone had, it would be great. But mm, how to explain it? Means if direct FD is not present, still that FD can be preserved, but it is preserved using the transitive dependency thing. When you will see in the question, you will understand it. So one way is this direct way which I told, other way is the transitive dependency thing.
Like A determine B and B determine C, then A determines
Yeah,
C.
then A is determining D is also being preserved. So by transitivity also, you can say that a dependency is being preserved. It might not be present directly, but indirectly it might be present. Okay.
Yes, sir.
The next part is equality between two sets. When two FD sets are considered equal, when F is, suppose there are two FD set F and G. When do we say that there is equality between them? When F is covering G and also G is covering F. Now we will check what is the meaning of F cover G and G cover F. So we will take steps one by one. What are the steps? We will, if we are saying F cover G, what does it means? That whatever FDs are present in G, all those FDs you can also find in F. That is the simple meaning of F cover G. This everyone understood? That whatever FDs are present in G, all those FDs are also present in F. So that's what we do while checking. What we do, you can see the steps and you can follow them and you'll understand. What we do, we will take first FD from G and we will take the closure of this FD in F. That means that we will take the closure of AB in F, and in taking closure of AB in F, if we are getting C, then we can say that this FD is being covered by F. Similarly, we will do for next also. For next FD, it is AB determining D. Now when we will take closure of AB in F, and if we are getting D as answer in the attribute closure, then we can say that this FD is also being covered in this one. Let's try this question very fast. Maybe you will understand. Okay, guys. So first, let's check for F cover G. So what we do, we will take first FD of G. So that is AB determining C. Now on taking closure of AB, first of all, tell me when we are saying F cover G, we take FD from G or F?
From
G.
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 Yeah, where we take FD from G and we take closure in.
F.
F.
So now tell me when we are taking closure of AB in F, what do we get?
C,
A B
A,
C
B,
D.
C, D.
Right. So C is present. That means that this FD is being covered in F. Now we'll take next, which is AB determining D. On taking closure of AB in F, what we are getting?
ABD,
A B C.
That means D is present. So again, this FD is also being covered. Similarly, we can check for C to D. Okay. Now let's see for G cover F. When we say G cover F, tell me we will take FD from F or G,
F,
F.
and
F.
we will check and we will take the attribute closure in.
G,
G.
G.
So now let's take closure of AB. First FD in is AB given CD. Now taking closure of AB in G, what are we getting?
ABCD,
A B C
A,
D.
B, C.
So that means we are getting this FD is being covered. Now let's check for B determining C. Okay, on taking closure of B in G, what are we getting?
B
B
only.
only.
D,
That means that we can't find C. That means F is not G is not covering F. Only F is covering G. This is the concept of covering. Everyone understood?
yes, sir.
Yes.
And
Yes.
and when do we say that there is an equality between two FD set?
F covers G and G
When
covers F.
F covers G and G
F
also
cover
covers F.
G and G
G
cover.
covers F.
Okay. You can practice this question. Okay, it is present in the slide. You can definitely follow. Then there is minimal cover. What is the meaning of minimal cover? Whatever minimum FDs we need to show all the FDs which are present in our original relation. That is canonical cover or minimal cover. Okay, so these are the ways how we do this. Whoever follow TA session, it might be very familiar for them, but as most of them present here are uh, not following TA session, so like this will be kind of new. So you can follow whichever method you like. There is nothing like this is compulsory or something. This is the method that I told to students. Okay, so we'll brush up again. Should we brush up using like a question only, right?
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
That's better. Let's not like go to steps directly. We practice one question and it will be clear. Okay, guys. So to find the minimal cover of any FD set, who can remember? Who can tell me what is the first step that I told?
We have to split.
First we split.
Decompose the relation.
Okay. What does decomposition mean? A given B, A given C, CD given E, E given C, so this is the first step. Okay, guys, those who don't know this method, it is not necessary to put your brain into this. If you can understand, it's fine. If you don't, you can follow the method that you are doing. Okay, so what do we do? The first step is decomposition, where what I have done, whichever FDs are having multiple attributes on the RHS side, I have made it into one only. So this was one ID was one was this, so I changed it into A to B, A to C. Then it was D given A to AEH, so I have again changed it to AEH separately. Then in this also it was there, and in those also. First part everyone understood.
Yes, sir.
Yes,
Sir.
sir.
Now what we'll do in the second part, we will find the extra attributes on the left hand side. Okay, so wherever there are more than one attribute on LHS side, there might be the case that there are more than one attribute is extra. So when do we say that one attribute is extra? Suppose you have AB determining C. Now I am saying that we will check whether if A or B, any of them is extra. So for doing that, what we do, we will take closure of A in our FD set. And in that, if we are getting B, that means B is extra and we will remove B. Similarly, how we can say A is extra?
Sir, if we do a
A
closure
is
set for
extra
B,
when we take closure of D and we find that there with B A is also there. That means A is extra. So now in our example, we will try to remove the extraneous attribute from the left hand side. So tell me which are the FDs which we are going to check. First FD which we will check is
CD.
CD determine
Determine E.
CD,
CD determining E. So on taking closure of C, what are we getting in our FD?
only C.
C.
That means D is not extra. Now we will check for D. Taking closure of D, what are we getting?
D A B C.
D,
D
A,
A C
A, C,
D,
H,
A,
E,
E,
H,
H,
C.
and
CB also.
H. So,
BC.
B C
So C.
also.
in way we are getting C, right?
Yeah.
Yes.
So that means C is an
Yes.
extra attribute. So we will remove C from our FD.
Or can you explain the second step again if you don't mind?
Yeah, I will. So what we did is that whenever there are more than one attribute present on the LHS side, there might be the case that one of them is extra. So you all have read the extraneous attribute thing now. So we are just removing extra attribute here. And how do we do? This is only for LHS side. What we do, suppose there is this kind of FD. So what we do, first we take closure of one attribute here, and then we check in that attribute closure if we are getting the second attribute. That means this attribute is extra and we can remove this. Similarly, we check for attribute closure of D, and in attribute closure of D, if C is present, then C is extra. So now, if in our this question only you saw that when I was doing closure of C, what I was getting? Only C. That means D was not extra. But when I was doing closure of D, what were we getting? We were getting D, A, E, H, and from A we were getting B, C. So we were getting C in closure of D. So that means C is an extra attribute and we will remove C. Okay?
So second step we have to take the one having more than one attribute, those things, right?
Correct. Only those. So we will take this FD and we will check for these FDs and we will check for DH. So CD, ABH and DH. These are the three that we will check in second step. Okay. We found one extra attribute, we removed it. Now we will check for more. Let's check for DH. So taking closure of D, what are we getting?
D A E H.
We are getting H. That means H is extra. So now what we will do? We will remove H also. Okay. Now we will check for A, B, H. On taking closure of A, are we getting?
A B C.
We are getting A,
So we're getting ABC alone.
Sir, your
B
voice
is
is
extraneous.
breaking.
B, C,
B is extraneous.
and what?
So your voice is breaking.
Sir, voice is breaking.
Is it fine now?
Yes, sir.
Yes.
Yes, sir.
Yes.
Sorry, actually, I think some network issues are there. There was rain yesterday, that's why I think the problem is. Okay, so when we took closure of A, you can see B is present. What does this means?
B is
B is extraneous.
extra.
B is, B is extra. So we will directly remove B. Now we will not stop here because still we have two attributes present. So we will also check whether in A and H there is some extra attribute or not. So taking closure of A, are we getting H?
No, sir.
No, sir.
That
No.
means H is not extra. Now taking closure of H, are we getting A?
No, sir.
No.
Only H.
That means A is also not extra. So we have removed all the extra attributes from left hand side. Congratulations. So now we will write all our FD again. So what we will do? Now we will write the new FD, which will be A determining B, A determining C, D determining E, E determining C, D determining A, E, H, A H determining B, A H determining D, D determining B, D determining C. I have just done nothing. I have just written the FD. After deleting those attributes, I have written the new FD. Till now, everyone understood what am I doing?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
Okay, what about the people who are seeing this for the first time? Are you all getting it? The new people?
Yes, sir.
Okay. So then there is the next step. Next step a little complicated, where we are trying to, in a simple way, we can say that we are just simply trying to find the extra attribute from the right hand side. Sorry. Okay. So in the next, what we will do is we will find the extra FDs now. We have removed extra attributes from LHS side. Now we will simply see whether there are extra FD only directly. How we will check this? Now understand this very carefully. In the third step, what we do, we pick one by one every FD and we hide that FD and we take closure of LHS in other FDs. Again, I'll repeat. One by one, we will take every FD. So first FD, we will take A given B. This FD we will take first. Now we will hide this FD. We will not delete it. We will just hide this FD and we will take closure of A in other FDs. So if we hide this FD, what are the other FDs that I am talking about? From this to this. In this, I will take the closure of A. On taking closure of A, what am I getting?
AC.
AC.
Anything else?
No, sir.
No.
No.
Right? So if on taking closure of A, if I would have got B, then I would have said that this FD is extra. Here I haven't got B here, so I will not say that this FD is extra. This FD is okay. But if when I am hiding this FD and still I am able to get A determining B, then we will say that this FD is extra. Everyone understood this?
Sir,
Let's
sir,
Yes,
in
sir.
the dependencies, you have written D twice. Can we just remove that once or?
Oh, okay, I have written that twice. That doesn't matter. Here we remove D, C, na. That's why it is showing two times. We can remove it. It won't matter. Wait, let me remove that. Hmm. Now fine.
Yes, sir.
Okay. So this is what we are doing one by one. I have checked for A determining B. Now I will check for A determining C. What I will do? I will take the FD. Now I will hide this
Sir, I had
FD.
a doubt, sir.
Yes, yes.
Sir, A determining B is okay, sir, but in the downside, AH determines B. Their H is an extra attribute, I think.
H.
Yes, sir.
Okay, let's
AH
check if it
determining
is.
B.
No, extra
Since
FD you are saying or extra attribute you are saying?
extra attribute, H is an extra attribute, I think, sir.
H is
Since
an
there
extra
is
attribute.
already determining A determining B, sir.
Uh, no. This is not how we check. Let me tell you the second step again, how we check. We will take closure of A. And if on taking closure of A, if we are getting H, then H is extra. Similarly, we will take
That's
closure
okay,
of
sir.
H.
But here, A determining B, sir. But again, A H determining B H. I think H is an extra attribute here.
No, no, no. H is not an extra attribute. FD might be extra, and
If
that
you
is what
remove
we
the
are
H,
checking in the third step. No, no, wait.
if you
This might happen that we just simply remove that full FD. This might be the case, and that is what I am telling in the third step.
oh, okay, sir. Okay, sir.
Okay, yeah. First, we were checking for extra attribute on LHS side. That we have cleared out. Now we are checking for directly extra FD. So what you are saying, just let me repeat, complete this step 3. I think you will get what like you are saying. Okay.
Okay, sir.
So for A determining B, what I did, everyone understood? Similarly, we will do for A determining C. We will hide this FD. So now in what are the FDs that we will check? We will check in this FD and these FDs. What we will do? We will take closure of A. On hiding this FD and taking closure of A, what are we getting? Remember, we are not considering this FD in taking
AB.
closure. We will hide this.
AB.
So we are
Only
getting
AB.
A, B.
AB.
That means A determining C is also not extra. Okay. Similarly, we will check for every FD which is present. Now we will take D determining E and we will hide this FD. So that means we will check in this FD and these FD. Tell me what we will get in taking closure of D here.
D A H
ABC.
B C.
And we will get D. We will get D.
BABH.
We will get C and what?
A and
A and
H.
H.
H and
A also, A.
A.
anything more?
So I have doubt
No.
of finding this closure.
So we are not getting E, right? What does that means? That D determining E is also not an extra FD. Okay. Now we will check for other next one, which is E determining C. We will hide this FD and we will hide this FD. So now we will check in these FDs and this FD. Can you tell me what is the closure of E here?
E only.
Only E. That means this is also not an extra FD. Okay.
So
Now,
here we can take transitive.
what?
Here can we take transitive relations?
No, 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 no. We don't check for transitive. See, that is another way, but we are not taking that method. I am just taking a very general method which like is there. Okay.
Okay, okay, sir.
You just have to follow these 3 steps. You don't have to worry about anything else. Transitive, this and that, nothing. So next FD is D determining A. That means that we will hide that FD and we will check in these FDs and this FD. On taking closure of D, what are we getting?
D
H,
H B
B.
C E.
Anything else?
No, sir.
No.
That means that this FD is also not extra. Now we will check for DH giving A. Sorry. D giving H. Sorry, man. So for this also we will hide that particular FD. We will check in these FDs and this FD. On checking for this, what is the closure of D?
D A E C.
B.
B.
Are we getting H?
No.
No, sir.
That means that this is also not an extra FD. Now let's check for AH determining B. So what we will do? We will hide this FD. We will take only these FDs and this FD. Now tell me what is the closure of AH?
A H D B C.
This is extra.
D.
Okay. So now we got B here. That means this is an extra FD and we will delete this FD. Now we will not hide, we will delete this FD directly. Okay. So the one who asked this question now might have understood what I am doing here.
Yes, sir. Yes.
Yes, sir. Now you got now?
Yes, sir.
Okay. So now let's check for others. So next is AH determining D. So again, we will hide this FD. We will check in this and this. So taking closure of AH, what are we getting?
AHBC.
Or,
Anything else?
so how are we getting B and C?
By A, no. See, by AH we got AH. Now by A we are getting B, and
Oh,
by
yes, sir.
C
Yeah,
we are
I forgot
getting.
to consider A.
Yeah. Only one ID we will, only one FD we will hide, which we are taking the closure of.
Yes, sir.
Anything else we are getting?
No, sir.
No,
No, sir.
That means that this is also not an extra FD. Now we will check for determining B.
sir. The FDs which we are deleting, we won't consider that in further checking,
No.
right?
They are gone. They are gone. Yeah, they are
Okay.
gone now. Okay. So now what are the FDs that we will take? This to this and this one. So taking closure of D, what we will get?
DACHE
D, A,
B.
B also we are getting, right?
Yes, sir.
Yes.
This is
Yes,
extra.
sir.
This is extra. We will delete. Okay. Now we will check the next FD, last FD, which is D determining C, taking closure of D, hiding this FD, taking in others. So we will take in these. So what are we getting?
DAEHBC.
Basically, you are getting C. So this is
Yeah.
also extra. So now we have done all the steps, and now we will write them in a simple way. We will write A determining B, A determining C, D determining E determining C, D determining A, then D determining H, and AH determining D. Now we can do the union of them. What is union means? That these two FD we can combine and write it as A determining BC. Then these three we can write together as D determining AEH, then E determining C, and AH determining D. And this is our final canonical cover or final minimal cover.
Sir, I have one question.
Yes.
Sir, how AH determine B removed? Can you explain once more?
How this was removed? AH determining B.
Yes, sir.
The same thing we did now. Okay, so what I did was I took the closure of AH. On taking closure of AH, what did I got? I got AH, and from A I got B, right? So that means B is present. So we
Yes.
will remove this FD. This is the way. The way we deleted these two, na, the same way we deleted this also.
Yes. Okay.
Understood?
Yes, sir.
So this is the way of finding canonical code. This might have been like you. It seems a long way because the question I took was very long. I don't know. Why I took this long question, but I took the long question. That is why this seem a very long steps. But if like you see the question which are present in PYQ, this will be a very simple step that you. Okay. I want to see what about the new ones which are present here. Was this method easy for you all? The new people who saw this for first time,
Yes, sir.
Yes, sir.
right? So if you want, you can follow this method. Okay, if you are facing problem, no problem, just follow the method which you know. That is also the right method. Okay, now the main problem to be solved for everyone is steps to find candidate keys. Okay, to find candidate keys, these are the steps which I have mentioned. First step is I will not say that check for one attribute, then two attributes, then another thing. I will simply tell you find a super key, and that is the easiest part for everyone, right? I am not saying that you find the minimal set already. I am saying that you find a super key. Super key everyone can find very easily.
Sir, excuse me. Hello? Hello?
Am I audible?
Sir, Mr.
Yeah.
Krishna.
Yes, sir.
Mr. Krishna.
Yes, Gaurav.
Sir, I have one question. It came last time. Like one relation has been given, and we have to decompose that relation, and we have to tell how much steps required to make it BCNF.
Okay.
So that was like I was totally confused for that. So because if that is, I think similar to this one, right? Because decompose is Yuti, keep quiet. 5 minutes. Decompose is the same thing, right?
No. That things come in normal forms. We are covering that portion in week 6. This is week 5. This is like a simple canonical cover and all those things.
No, no.
The
I
thing you are
agree.
telling
What
is
I'm
in
asking is
normal forms.
decomposition of any schema of based on the
Okay.
FP, it will remain same, right?
Mm, same as
Like,
in.
same as in same. It should be same as in A equal to B. Sorry, A equal to A. Like when I'm decomposing for a schema for checking BCNF, or I'm decomposing to checking canonical covers, anything. The decomposition will be remain same, right?
Mm, I really didn't understood the question. Like decomposing into BCNF has no relation with canonical cover and those things.
No. First step is we have to decompose them, right?
Hmm.
Agreed. That decomposition part remains same for both.
Yeah.
Okay. So because that one like is given like a if you
See,
can write.
this decomposition I did here, this is just to make it a little simple. If you are finding for A determining BC, it might be a little hectic. So that's why just to simplify that step, I did this. It is not like a very big of a
No, no,
thing.
no. Your step is very nice because that one that way is very easy. Nothing to think about. Just follow the step and go through Allah tool. That I agree. But
Hmm.
because on this one, I have this that question. I had big problems regarding
Actually,
decomposition.
I'll suggest that if you can show me that question, then it will be better. I
Okay.
can tell you
How
in a
do
good
I
way.
show that one? I share my screen, right?
You just find it out after like
No, I already
completing.
find it out.
Okay, so after we'll complete this revision session, at the end we'll take that out. Is it fine?
Okay. Yes, sir. Thank you so much.
So for candidate keys who are suffering problem in this part, very simple step. First thing is find the super key in the relation, okay, and then break it. For example, I am saying that there is a very big FD set, and you randomly find out that if you are doing the closure of A, B, D, then you are getting all the attributes. So you found a super key. Now what is the next step? You will find the minimal subset from this only. See, directly finding the candidate key might be tough, but finding a candidate key from a super key is easy because you have confined your super key. Now what are the possible candidate key that you can get? It can be A, it can be B, it can be D, or it can be AB, BD, or AD. Correct? So I will not say directly find the candidate key. I will say first find super key and then break it and see if you can find a candidate key in that. So if you found some super key like this, then you will check for closure of AB maybe. And when you check for closure of AB, you found this is also determining your all the attributes. Now you saw that if you are taking closure of A, then this is also determining all your attributes. So this way you discovered your candidate key directly, right? So this will be a little easy way. So first step is find a super key and then see that if any subset of that super key is giving you all the attributes. This way you will find your one candidate key. Second is those attributes which are not present in the RHS side of your FD set. Those are definitely present in the candidate key set. Third step is there is only one case where multiple candidate keys are present. What is that case? Everyone understand this carefully. Suppose you find one candidate key and that candidate key attribute is present on the RHS side of other attributes. then a multiple candidate keys can be present. Just let's do one thing. Let's start with the question. That is the best way. The way we did canonical cover, we will do this in that way only. I am like covering this thing in great detail because these are like important topics for normal form also and everything. These you need to get. So what we do is first we find a super key. Just randomly take anything. Like I am taking AB closure. Taking closure of AB, am I getting all the attributes which are present here?
Yes, sir.
Yes.
Are you sure?
Can I
Yes,
say
sir.
something?
No,
A, B.
no, we are not getting G, F and G.
G and F.
Correct.
G.
So that is what. First of all, whichever attributes are not present on the RHS side, those attributes are definitely need to be taken in a candidate key. So as F and G are not present, I think the question is wrong. I got the wrong question. Sorry. The first question is wrong. Don't check it. Okay, so this is the question. So what is the first thing? We will take a random thing, which is A, B. On taking closure of AB, what are we getting?
A, B, C, D, E, F.
Okay, now what we will not claim that this is a candidate key. First, we will check whether taking closure of A or taking closure of B, are we getting all the attributes? On taking closure of A, we are getting only A, and on taking closure of B, we are only getting B. That means that AB is our candidate key. Okay. Now what is the next step? To find whether there are multiple candidate keys or not. What do? We check whether any of the prime attribute is present on the RHS side in our FD. Just tell me, when you got ABS candidate key, what are the prime attributes?
A and B.
A and B.
A and B.
Now we will check whether A and B, any of them are present on the RHS side or not. Can you find any of them?
Yes, sir.
F.
B
Yeah,
and
Yes,
B.
sir. B.
B is present. Now what we will do? We will replace B with F in our candidate key and we will try to take the closure of it. Okay, so basically what I am saying is whenever you find prime attribute on RHS side, you replace that attribute with the LHS. So AB was our candidate key. What we will do? We will replace B with F. So here we will do F. Now we will take the closure of this. Are we getting all the attributes?
no, sir.
A, F, B,
Yeah.
C, D,
Yes.
E, F. Yes, sir.
That means that AF is also a candidate key. Now what are our prime attributes?
A,
A,
B, and
B,
F.
A,
F.
B.
ABF.
Now we will check again. Can you see that at RHS any of the prime attribute is present?
Yes, sir.
Yeah, F is present
F is present.
So what
on
we will do?
RHS of E.
We will replace the LHS with RHS. So now we will see whether AE closure is giving us all the attributes. Are we getting?
Yes, sir.
Yes, sir.
Yes.
Yes.
That means that AE is also a candidate key. So in prime attribute, we got E also. Now can you see again, is this case arising where E is present,
Yes, sir.
any of the prime attribute is present on the RHS side?
Yes, sir.
So
Yes.
we will do the
D
same thing
determined.
again. We will replace E with D. So now we will take closure of D. And on taking closure of D, you all can find that we will get the all the attributes. So AD will also be our candidate key. So D will also come in the prime attribute. Now again we will check whether you can see LHS prime attribute.
Yes, sir.
Again it
C.
is there. So
Yes.
now we will again replace the RHS with LHS. So it will become AC. On taking closure of AC, what we will get? We will again get all the attributes. So AC will also become our candidate key. So C will also be our candidate key. Now you can see this condition again. Yes, it is there, but AB we have already taken as our candidate key. So we will not repeat this again. Right? So what are our candidate keys? AB, AF, AE, AD, and AC. So there is only one case where multiple candidate keys are present. And what is that case? What is that case?
When a particular attribute is not there on the right hand side of the FT.
No. I am asking that when multiple candidate keys are present, where what is that case? That happens when any of the prime attribute is present on the RHS side.
Right side, yes.
Yes. In that case, what do? We replace that particular RHS to LHS, and then we take the closure of it to confirm whether this is happening or not. That's what I did. B was there, so I replaced B with RHS. We will not replace the whole candidate key. We will only replace that particular attribute which was present. Now suppose in this question, instead of F determining B, it was F determining A, B. Just tell me in that case, what closure you would have taken? You would have taken the closure of AF, BF, or what?
F.
Only F.
Only F. So this is a very important thing to remember, that we replace whatever is present. So AB was our candidate key and whole AB is present here. So we will replace whole AB with F. Whatever attribute is present on the RHS side, we replace whole that attribute with LHS. Here only B is present, that's why we replaced only B. If both AB were present, then we would have taken closure only of F. So someone was facing problem in candidate key. I think
Yes, sir.
you are good with it, right?
Yeah.
Now,
Yes, sir. Yes, sir. I got it now.
you can do one more thing. This live session, this is present in live session PDF with week 5 PDF name. There are 2 more questions. Practice these, and more questions are there obviously in PYQ and everything. Practice more and more questions. You will get this concept.
Okay,
Just see these steps which are mentioned here. Repeat this, and you will be good.
Okay, sir.
Yes, Suresh.
So safely we can ignore the other combinations like CD or DE, DF.
What?
I mean, can we safely, ignore other combinations?
Yeah, you can. See, when you find one candidate key, and if there are multiple candidate keys, the only way you can find is this way.
Or EF
If
or
yeah,
DE candidate keys to check for.
if you want all the candidate keys, this is the only way. If you go like manually checking, you might take very much time, and some you might get, some you might not get. But this way, I am like confirming that you will get all the candidate keys which are possibly present there. Okay, just these 3 steps. So in 3 steps, your candidate key is covered. In 3 steps, your canonical cover is covered, and rest was so easy only. Let's go for week 6. This for week 6.
Sir, where can we get this PDF?
In live session
Hello.
PDF, you can get. In
Supplementary content.
yeah, supplementary content, you can. Anyone please share the live session PDF, this folder link.
Okay, sir.
Let's go with week 6 now. Okay. So week 6 contain normal forms now. So one by one we will cover normal forms. So in 1NF, only one condition is there, that there should be no multi-valued attribute. What is the meaning of multi-valued attribute? Suppose A and B, there are 2 columns in your database. Now in B there are 2 values, 1 comma 2. So this is called as multi-valued attribute. So no multi-valued attribute should be present in your database or in any relation. That is known as 1NF. Now for 2NF, what is the condition to see? See, there are many ways to check this.
Sir, your screen just freezed.
Is it okay now?
Yes, sir.
Yes, sir.
It was okay
So now-
earlier also.
Okay, I think it was with. So now we will check for 2NF, 3NF, and BCNF. Understand these things very carefully. What do we do? Or maybe I'll start with question only. No. First, let me tell you. What do we do in 2NF?
Sir, 1NF, so the 1NF.
Only one case is there that it should not be multi-valued. Nothing big is there. Okay.
Okay.
Now let's check for 2NF. For 2NF, what is the way that we check? We will first find out the candidate key. Okay. Then after finding the candidate key, we will check this type of FD should not be present in our FD set. First, tell me what is the meaning of proper subset. If I am saying AB, what is the meaning of proper subset? What are the proper subset of AB?
A
or B.
B.
Okay. So in proper subset, that particular value doesn't come. Only its subset come, right? So I am saying that suppose you found a candidate key from you have been given FD set and you find a candidate key AB, right? Now you are getting in your FD set there is a FD of type where LHS is proper subset of candidate key, which means that LHS is either A or B. And also the RHS that you have, that RHS is a non-prime attribute. What is the meaning of non-prime attribute?
Which is not the member of candidate key.
Correct. So if this type of FD is present in your relation or in your FD set, then it is not in 2NF. This is how you check for 2NF.
Sir, both of these properties should be for the non-prime attributes.
Correct. If LH, first you will see, first you will only check for prime proper subset of candidate key in proper subset of candidate key in LHS. If there is no FD where there is proper subset of candidate key, if there is no such FD, then it is already in 2NF. You don't have to check then.
Okay.
Only if on LHS side proper subset of candidate key is there, then you will check for RHS. And if for those FD RHS is having a non-prime attribute, then you will say that this FD is not in 2NF. If suppose LHS is a proper subset but RHS is a prime attribute, then this will be in 2NF. Also,
means any
LHS
of these violates it will be in 2NF.
Yeah. Okay. So in simple ways, first thing is if you will in all the FDs you will look for whether in any of the FD LHS is proper subset of candidate key. If yes, then only you will check for RHS. If you find no FD which is having proper subset of candidate key in LHS, then you can say that it is in 2NF. Then you will not check for RHS. You will only check for RHS when LHS is a proper subset of candidate key.
Okay.
If LHS is proper subset of candidate key, then for RHS you will check whether RHS is a prime attribute or non-prime attribute. If RHS is a prime attribute, then it is in 2NF. But if RHS is also non-prime attribute, then it is not in 2NF. Okay. This is the simple way of checking for 2NF.
Thank you.
Now
Okay,
for
so,
3NF, what?
Excuse me.
Yeah.
So can we say in 2NF that if if prime attribute is pointing towards the non-prime attribute, then it is not in 2NF?
If prime attribute
is pointing towards the non-prime attribute.
No, that can't be said. You have to check for proper subset of candidate key. If that prime attribute is in a way, suppose you get AB as a candidate key. Okay, now this AB is pointing towards a non-prime attribute. Then also this is in 2NF.
Oh,
Why?
yeah,
Because this
exactly.
is not a proper subset.
No.
But if you are saying that you got AB as a prime as a candidate key, but you are saying that this attribute is pointing toward non-prime attribute, then this is not in 2NF. Understood?
Yes. Got the difference. Yeah. Thank you.
Now we will see for 3NF. First, let's check for
Sir, give an example.
Wait. First, let's see for okay. Let's take the example only. Okay. For question number 1, first of all, tell me what is the candidate key. If you are taking closure of AB is a candidate. Yeah, if you are taking closure of AB, what are you getting? You are getting AB, CD, then you are getting E, you are getting, then by E you are getting P and G. So AB is the candidate key, right? You got your candidate key. Now you will check whether in any of the FD, can you see that LHS is a proper subset of candidate key?
B determines.
This one. Now you got that FD. Now you will check whether RHS is a prime attribute or non-prime attribute. So is G a prime attribute?
No, sir.
That means that this is not in 2NF. Understood?
Yes, sir.
Sir,
Let's
can you
check
repeat?
for.
Yes, sir.
Okay.
Can you repeat?
I am saying that AB is a candidate key in our this question. This you understood?
Yes, sir.
Now I am saying that can you see any FD where LHS is a proper subset of candidate key?
Yes, sir. B.
Now we will check that in that particular FD is RHS a prime attribute or non-prime attribute.
No.
So is G a prime attribute?
No.
No.
No. That means that this is not in 2NF. If this was a prime attribute, then it was in 2NF. But this is not a prime attribute, so this is not in 2NF. Understood?
Okay, sir.
Let's check for next question also. Just tell me what is the candidate key in this case.
AB.
AB.
AB again.
Now, can you find any attribute where LHS is a proper subset of candidate key?
No, sir.
No, sir.
No, sir.
No. That means that this is in 2NF. Okay, next, take question 4. Tell me what is the candidate key here?
B.
What?
A is a
A.
candidate key.
A is the candidate key.
So by A, you are getting all the attribute, right?
Yes.
B is also.
No.
Yes,
Take
sir.
question 3. Sorry. Take question 3. Tell me what are the candidate key in this one.
AB.
And
AB.
And AD.
the one
Sorry,
AB is one
AB and
candidate key,
AD.
but there can be multiple candidate keys. Why? Because A is present on the RHS side. So AB is candidate key and AD is also a candidate key. Now tell me
Sir,
where
DB.
can you find DB also. Now can you find whether LHS is a proper subset?
Yeah,
Yes, sir.
D.
Yes, sir.
D.
Yes.
But check for RHS. RHS is a prime attribute or non-prime attribute?
Prime
Prime.
Prime
attribute.
attribute.
Prime.
That is why this is in 2NF because RHS is a prime attribute. Understood the difference?
Yes, sir.
Yes,
Yes,
sir.
sir.
Right. Okay, so
Sir, how long this session will continue?
just some part is only left. Okay. I think we'll wrap this up by 8:30. Is it fine with everyone if we extend
Yes,
to
sir.
half an hour more?
Yes, sir.
Yes,
Yes, sir.
yes.
Yes, sir.
So will you
Very
be
fine.
uploading this video immediately after the session?
This is on the
It is live.
YouTube.
This is streaming.
Oh, okay. Thank you, sir.
सर वो क्वेश्चन बताकर जाना.
हाँ. Don't worry. I'll go after telling you that question. Okay. So now let's go for 3NF. Okay. So first condition for 3NF is that it should be in 2NF. So whenever you have been asked a question where you need to check for 3NF, first check for 2NF. If the relation is in 2NF, then only you can check for 3NF. Now what is the condition for 3NF? In 3NF, what do we check is that in your FD, if there is all FD should be like this. In what way? Either the LHS should be a super key or the RHS should be a prime attribute. Any of the two condition can be there. Like in 2NF, we only check for RHS when LHS we got as proper subset. Only then we check for RHS. But here we will check for both conditions. First we check whether X is a super key. If it is like following 3NF. But if X is not a super key, then at least RHS should be a prime attribute. Okay, any of the two conditions should be true for every FD. Either the LHS should be a super key or RHS should be a prime attribute. Let's check for every question. First of all, first question was not in 2NF. What does that mean? Is can it be a can it be in 3NF?
No.
No.
No, sir.
No.
Let's check for second question. What was the candidate key that you got?
AB.
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 AB, right?
Yes.
Now tell me,
Yes.
which is the
Yes, sir.
FD where in second FD, can you see that LHS is super key?
No, sir.
No.
Okay, that's fine. But here we will not say that it is not in 2NF. Now we will check for RHS. Is RHS a prime attribute?
No, sir.
No.
No.
So none of the two condition are getting followed. That means that this is not in 3NF. Let's check for next one. AB determining what was the candidate key here?
AB.
AB.
AB and
AB and the AD.
AD.
AD
now
also.
tell me. Okay, in this one is LHS a super key?
No, sir.
Yes.
No. It is not a super key.
Oh,
So
yeah,
Not
it
it
is not.
cannot be less, right? Okay,
Yes.
but now we will check for RHS whether RHS is a prime attribute. Yes. So
Yeah,
this
Yes.
yeah.
is in 3NF. Why? It is fine that LHS is not a super key, but RHS is a prime attribute. So this will be in 3NF. Now, what is the condition for BCNF? BCNF holds only one condition, a very simple condition, which is first of all, it should be in 2NF and 3NF both.
Okay.
There only be super key, nothing else. So first of all, this was not in 3NF, so this cannot be. This was in 3NF. Let's check for BCNF. In this FD, LHS was not a super key, right? So
Yeah.
this will not be in BCNF. Now let's check for this one. What are the candidate keys which we can find here?
AB.
A is a candidate key, B is candidate, DE is
A
candidate.
is a candidate key, B is candidate key, and DE is also a candidate key. What does that mean? That in every FD, LHS is a super key. So this will be in BCNF. Understood?
Yes, sir.
Yes, sir.
Okay. Guys with normal form now, anyone having doubt? Just
Sir,
read this slide once more and
excuse me,
you will
sir.
be good with it. Yes.
Sir, here if every functional dependency has to be checked.
Yes. Every functional dependency have to be checked. When we are saying for 2NF, we will check this particular condition for every FD given in our FD set. When we are
Okay.
checking for 3NF, we have to check for all the FDs. Okay, for this
Okay.
condition.
Okay.
Okay, then. Okay, guys, these are just the steps for 2NF decomposition and all. This I am not covering here. I have covered this in TA session very properly. You can check there. Those who are having problem with this decomposition part. Okay. Uh, in that TA session, it is there. Because like we are also out of time, so now let's go with week 7. Okay.
Sir, but 4NF, sir.
What?
Sir,
Four.
question can I ask?
How to identify 4NF?
For 4NF, those 4 conditions are given. Okay, I don't think I have a slide for this. Wait a second.
Sir, it's in week 6 slides.
Yes, I know.
Will you be covering MVD also?
Yeah, I'll try.
Okay.
Okay, so in MVD, what you need to know is just one thing. What is alpha, what is beta, and what is R minus beta? First, tell me what is alpha.
First attribute.
Alpha is LHS. Alpha is LHS. What is beta?
RHS.
Beta is RHS. And what is R minus beta?
Rest of the alpha and beta.
Leftover attribute.
Leftover attributes other than RHS. Other than RHS, whatever attributes are there, those comes in R minus beta. So now there are three conditions for MVD. This is the table and we will check one by one for all. What is the condition? That for our 4 rows, the value of LHS should be same. Okay, now here what we are saying, that SID is determining instructor comma instructor row. So for all 4, the value should be same. You can see all the 4 values are same. All are having same SID. First thing we check. Now what is the second thing we check? That for RHS, for the RHS, first and third row should be same and second and fourth row should be same. When we are saying SID instructor comma instructor room, what is RHS? Instructor comma instructor room. So we have to check that first and third row should be same and second and fourth row should be same. Okay, so first row and third row and I think this is not an FD. Let's check for this one. First one, SID comma S name giving course. So first is that LHS should be same. So you can see LHS is same, ME1001 and David. So it is same. Second is that RHS, for RHS, first and third should be same and second and fourth should be same. So you can see first and third is same and second and fourth is same. Now what is the next condition? That for rest of the attributes. Okay, tell me what will be R minus beta here.
Instructor and
Here R
instructor
minus
room.
beta will be SID, S name, instructor and instructor room. This will be R minus beta. Now they are saying that for R minus beta, second and third row should be same and first and fourth row should be same. So you can see what is second and third row. M001, David, SN Joseph, 505. Similarly, this is also same. Now first and fourth is also same, you can see. Okay, so this is following MVD. So just this much you need to know about MVD.
Okay, thank you.
Okay,
Yeah.
nothing more. And if you talk about 4NF, that how to convert it into 4NF, you just simply have to do that whichever MVD is there, you just have to take out from the relation and make a separate table of it. Then it will be in 4NF. That's it. Okay. Let's go with week 7 now. This is week 7 file.
Sir, Krishna sir,
Yes.
that question related to this one only. You want to take now or later?
I'll take later. Like let's just
Okay.
this. Yeah. So that like those whose work is completed, they can leave. No. Week 7. I cannot find week 7 here. See, week 7 is mostly the theoretical part only. So I'll just look fast whether there is something which is important to tell, and only that thing I will tell. If it is only theoretical, I am not telling those things. I'll just revise the concepts only. Is it fine, na? You all can read these
Yes, sir.
things.
Yes.
Try to waste time on these things.
So, do you have any idea when the mock paper would be released?
I think it will be released soon.
Tomorrow.
Okay, sir.
Yeah, maybe tomorrow something. I am not sure. I'll.
Excuse me, sir.
Yes.
Sir, I have a question regarding MVD.
Okay. We'll do it after this. Okay. So week 7, there is nothing that I need to cover. Okay. Let's go with week 8, the last week. In week 8 also, I think there is this binary search tree which like needs some covering. Everyone know how to draw binary search tree?
Yes.
Anyone
Yes.
facing problem in making a binary search tree,
No,
or how
sir.
to find the height, or what is the level or anything? Okay, everyone knows stack, queue, and all those things. Anyone having problem in that?
No, sir.
No, sir.
No, sir.
Graphs and this all. Okay, there is no big thing in this. Yeah, in 8 also, there is nothing which is there to like
So
make you all
bitmap
understand.
is will be covered tomorrow, week 9 to 12.
What? Yeah,
Bitmap.
week 9 to 12, I think one more revision session is there, na? In
Yes.
that it
Yes,
will be
sir,
covered.
statue.
Week 9 to 12 more will be covered in that.
Okay, sir.
Okay, now for week 8, the important thing is these formulas. These are present in live session PDF. So these formulas once go through. Other than that, I have also like
Sir, can you
let
just
us say
tell
three.
about MTTF formula once?
Okay, that is not important. Don't worry.
Okay, okay.
Like only one question was given, and in PA in P or G it was given, but in PYQ I didn't found any question there. Okay, then these extra questions are there. This PDF of extra questions. This is present in live session PDF. So in this, just see these questions, and I think you are asking for MTTF, na? Just see this question, Devanshu.
Yeah.
Yeah,
Okay.
see this question, and you will be good to go. This was the question which was asked in PYQ only. Okay, so they see this question. Sorry, see this PDF, everyone, and
Okay,
you will
sir.
be good with week. Okay. Now, first of all, tell me in concepts anyone is having any doubt?
Sir, when we talk about a super key,
Mm-hmm.
it is when it contains the candidate keys, right?
Correct.
And it should contain all of them or any one.
Uh,
I keep getting
Anyone can be
confused
there.
with,
For example, if you get AB, AC, AD as candidate key. So what are the super keys that you can make here? Suppose your relation have A, B, C, D, E, F. This is your relation, okay?
okay,
And
sir.
you got these as the three candidate keys. So what is your super key? It can be A, B, D, okay? It can be A, B, E. It can be A, B, F. Other than that, it can also be ADE, ADF. It can also be ACE, ACF. Okay, so super key should contain at least one of the candidate keys.
Okay, sir.
Okay, and it can contain all also. As you can see, this is itself a super key.
Super key, correct.
Yeah.
Yes. Okay, thank you.
Sir, finding the number of super keys, can you tell that thing?
Mm, uh, Finding the
If the
number of.
number of candidate keys are given.
Okay, so for that there was a PDF. I don't remember where it was,
Sir,
but you can
page
find
5.
in live session PDF. Anusha ma'am did uploaded that PDF. Just find that PDF and you will
Uh,
get all the formulas there.
it is,
Okay, sir.
I have sent the link on.
Oh, okay. He has sent the link also. You can check that. Yes. Concept wise, any problems anyone is having? Yes, Suresh.
Also, this minimum and maximum binary
Minimum and maximum
trees. Yeah, if you
binary
can.
tree. Okay. See,
How find
the case of
minimum?
max. Okay, I'll just simply show you the that question only. It will be better if you understand from that. See, the maximum height of a binary tree can only be the case when your binary tree is in this way or in this way. Okay, that means that all the values that you were given in ascending order. For example, if I am saying 1, 2, 3, 4, 5, 6. So how you will create a binary tree from it? You will do 1, then you will do 2, then you will do 3, then you will do 4, then you will do 5. So you can see that from these attributes, we have achieved the maximum height that we can get. So this is the case for maximum height. Okay, when your data is given you into ascending order. In that case, you will just create a
So here the height will be of 5 or 6 actually.
what?
So here the height will be 6 or
Height
will it
will
be
be
5?
wait, level 0, 1, 2, 3, 4, 5. Um, it will be, the height will be 6.
Sir, height will also be 5.
No,
right?
sorry. Height will be 5. I'm sorry. I just got confused. Height will be n minus 1. So number of nodes are 1, 2, 3, 6 nodes are there. So height will be n minus 1, which is 5. And if you talk about level, so level 0, level 1, level 2, level 3, level 4, level 5. So 6 levels will be there. I just got a little confused. Levels will be 6 and height will be 5. Okay.
Okay. Sir.
And
Minimum.
similarly, minimum height is the case when there is a balance tree. You all know what is a balance tree, right?
Yes, sir.
Yes.
So in that case, how to find the, so this is a formula where L means level. So 2L minus 1 should be greater than or equal to 15. What is 15 here? Number of nodes. So this way you got L, and height is always 1 less than the level. So you got 3 as the height. Okay, so this is the formula for it. 2 to the power L minus 1 should be greater than or equal to 50. This way you will get the level, and from level you can find the height by subtracting 1. Okay, this question was also there. Search tree contained 31 elements. So again we have to find the minimum height. So same formula, 2L minus 1 greater than equal to 31. So this way we got L as 5. Then height was L minus 1, which was 5 minus 1, 4.
Hello, sir.
Yes.
Sir, it means here we started the naming of level from 1 and the node is start from 0. Like height is started from 0 and label is started naming from 1.
Correct. Level start from 1. Number of level is 1, but first level is 0. Level 0 and the number of level is considered as 1. Okay.
Okay, sir.
So now if there are no concept-wise doubts, I can take the questions which were there.
Yes,
Sir, can you
So,
please solve
okay.
one this question?
What?
This question.
This question.
Yes, sir.
Okay, for this question, you can see this. I have very properly mentioned all the steps in this one. I think you will get from this. So please just see these this PDF ones, this extra question we get, and also this formulas for magnetic disk type numerical we get. Just see these two PDF, and still if you don't get them, you please come in tomorrow's TA session, and there we will discuss it. Is it fine?
Yes, sir. Thank you.
Okay. Yeah. Okay, so now those who want to leave, they can leave, and now I'll just be taking the questions which were there. Okay, those who want to leave, they can leave. Revision is done. Okay, so yeah, there were some doubts. Gaurav,
Yeah, sir.
please.
Sir,
Yeah, please.
I'm sharing screen now.
Sir, one question.
Mm-hmm.
So whatever you gone to today is available in the lesson PDF, right?
Whatever.
Whatever.
Sir, can you see?
Through whatever PPT or.
Yeah. All I have, all the things are there only in PDF. Don't worry. You can see in the live session PDFs. All are there.
In live.
Sir, can you see my screen?
Just a second. Let me stop streaming. The revision session is done. Okay. Yeah. Now tell me, what is the question? Consider the